Hello and welcome back to this series on shapes, and today I'm going to go through a worked through example which is similar to questions that may come up in a GCSE exam. So this is the question: what is the total area of this shape? So this video will also contain a bit of advice about how to answer these questions in an exam. First of all, break it down into things that you know. So when I look at this shape, I see that there is a rectangle, a quarter of a circle and a triangle, and the total area of the shape is going to be the sum of all that. So I'd start off by just actually writing down a formula which is pictographic to show this. So I'd say that the rectangle plus the semicircle plus this triangle is equal to the area, which I'll call A. And I've put them in this order because looking at this seems to be the easiest way to, I'm starting off with the easiest shape first and then progressing in difficulty. So again, in any question in an exam, make sure you start off with the bits you can do first, because even if you get stuck later on, you will still get some working marks for what you've done up till that point. So as I look through this, you can see that this rectangle, so I'll actually just put it in on a dotted line in blue, has a height of 2 and the length of it is going to be the 6 minus this bit of the circle, which is going to take it to 4. If I look at this semicircle, or quarter of a circle, it's got 2 and 2, and as the only information I know about this triangle, other than seeing that it's a scalene triangle, therefore I don't know the height of it, I can see that the semicircle minus the full length is going to be the base, so it's going to be 4. This here is 3, and this is 120 degrees. So I can start working through the bits that I know now. So the area of this rectangle is just the length times the base, so that's 2 times 4. Plus, this is the area of the circle, which is pi r squared. So this is pi r squared, which will be 2 squared. But I only have half or a quarter of the circle, so this is the right angle. So this is 90 over 360, or a quarter. So I can multiply this by a quarter, which is the same as dividing by 4, is equal, or plus, then I'm going to have half the base, which is 4, times the height, which I'm not sure yet, of this triangle, is equal to A. So I can now start tidying this up. So I've got 8 here, plus, so 2 times 2 is 4, so I have pi, plus this 4 over 2, which is just 2h, is equal to the area. The problem is I do not know the height of this triangle. However, what I'm going to do is draw it out in large over here. And what I can do is, if I go with green pen, I can draw a second triangle, which is a right angle triangle. And I know how to find the height of a right angle triangle. I can either use Pythagoras or trigonometry. So there's my right angle. And because this is a straight line, doesn't look like a straight line, it's meant to be a straight line, this is going to be 60 degrees, because the angles on a straight line have to add up to 180, and I've already got the 120 here, so this is 60. And I'm going to look for the h, which is over here. So I've now got this triangle, and I can't use Pythagoras because I only know one length of one side, so I'm going to have to use trigonometry. So in the previous video I've used SOHCAHTOA. So I'm going to label these up. So this is your hypotenuse. This h, lowercase h, is your opposite. This is your adjacent. So I know I'm looking for the opposite. I know the hypotenuse and I know the angle. So I can use sine. So going for the SOHCAHTOA, the sine of the angle is equal to O over capital H. I can fill this in. So I have sine 60 is equal to what I'm looking for, which is lowercase h over 3. I can rearrange this. So h is equal to 3 sine 60. So I'm getting the calculator for this. So 3 sine 60 equals 2.6. I can now fill this into here. So we have 8 plus pi plus 2 times 2.6. So I've got 8 plus pi plus 2 times 2.6 is equal to 16.34. Let's make all the centimetres. So this would be, we always have to put the unit in, centimetres squared. So always remember your units, they are important. We can sort of take a rough assumption about how big this shape is. So if we took this to be a rectangle, we have 2 by 6, so you know it's probably going to be bigger than 12. So we can carry out a little bit of a sanity check, and providing our answer is bigger than that, we probably are on the right lines. So that's how to answer this style of question. Next time I will look at using Pythagoras to calculate the area of a complex shape. Thank you for watching, and I hope to see you in the next video.